Now we're here at Big Kaiser's booth, W1600, and we're talking with Jack Burley. Hi, Jack.
Hi, how are you?
I'm great. So tell us what we're looking at here.
Well, today we're looking at digital technology in our tools, and one of the things that we try to improve upon is ease of operability with our tools with the operators, eliminating mistakes, eliminating any scrap that they might have.
So, what's the pro about having the digital display here?
Well, the digital display allows the operator to actually look at a display and read it as he's adjusting the tool, which correlates basically to what he's using on the shop floor. Easier to use, really takes away all the mistakes involved with the old type of technologies. Digital is really the new wave of manufacturing, and we've taken it into the digital boring systems as well.
All right. And so, what sort of applications is this used for?
These tools are for precision boring in any kind of industry, automotive, aerospace, precision die making, basically anything with high precision mechanical hole making systems.
Okay. And I know you have something else to show us right over here, so let's take a look. So, now we're going to look at your solutions for deep hole boring. Tell me about these.
Well, we know that it's always easy to do holes when they're not very long. You know, we have some very easy to use tools, very short. They work very, very easy and economical. But more and more, we're getting deeper and deeper holes. And to do this, we have to come up with solutions to provide really deep hole boring applications. And what we do to solve that problem is we usually put in some sort of a system like a D-Vi bar or a solid carbide bar, which compensates for vibration. And that's usually what we're always trying to overcome is a lot of vibration whenever we're trying to do really deep hole boring.
And what is the problem with that? Tell us again.
Well, in deep hole boring, the vibration is really problematic because it causes a lot of bad finishes. It's really unproductive. The quality of the hole is never very good, and the tools run extremely slow.
So another trend that we're seeing here is lighter weight materials. So you have an example of lightweight materials right over here. Let's check it out.
Here's two typical examples that we have from customers that might be working with our tools. The one on the left is a traditional steel tool built up, weighs about 100 pounds. So a lot of machines are going to have a hard time with it. Certainly the operators who have to handle it are going to have a hard time with it. The one in front of it, which is a different color, is different material. It's about a third of the weight, only about 30 pounds. So it does the same thing, works the same way, is able to do the same job, but much, much easier for the machine and operator to handle.
So where are these restrictions on weight coming from?
Well, certainly the operators themselves, the unions are dictating certain weight limits that their users can handle without putting cranes on, but also the machines. They're automatic tool changers, and they have certain weight limits that they can handle. And once we go beyond those, especially with long tools, then they have to be hand loaded by the operator. And that's what we're trying to get the customers to avoid.
All right, so Big Kaiser has the solution.
Yes, we do.
All right, well, be sure to stop by Big Kaiser in the West Building, booth 1600.